You know that weather forecast you check every single morning? What if I told you it's missing a key ingredient? I mean, a huge one. A hidden force that's actually shaping our clouds and our rain. Something we've pretty much completely overlooked. Okay, let's get into this, because we're about to explore a really radical new idea about what actually makes our weather tick.
Forever, we've thought of weather as a story told by physics. It's all about temperature, atmospheric pressure, the way water moves around. Simple, right? But it turns out there might be a secret character in this story, a biological one, that's been pulling the strings this whole time.
And this leads to a really wild question. What if our entire understanding of weather as this purely physical machine is just incomplete? What if we've only been looking at half the picture?
So here it is, the big reveal. The missing ingredient isn't some new subatomic particle or strange energy source. Nope, it's life itself. The whole idea here is that living organisms, and we're talking trillions of microscopic ones, are playing a direct, active role in creating the weather we see every single day.
Okay, so this takes us from right here on the Earth's surface all the way up into the atmosphere, into the world of clouds. And the main characters in this part of our story, they're incredibly small, but their impact might just be absolutely enormous. We're talking about microbes.
The scale of this is just mind-boggling. Microbes are literally everywhere. In the soil under your feet, on the leaves of plants, in the spray coming off the ocean, and because they're so tiny and so light, a simple gust of wind or the splash from a wave can just sweep them up by the billions, launching them on this invisible journey miles into the sky, and that's when they get a new name, bioaerosols. So let's follow one of them, right? A single microbe is just hanging out on a leaf, and then whoosh, the wind kicks it up. It's now an airborne particle, a bioaerosol, just drifting along until it ends up inside a cold cloud. And right there, that is where the magic happens. In that cloud, it does something pretty amazing. That amazing thing is basically their superpower. You see, certain microbes are what scientists call ice-nucleating particles, or INPs. The best way to think about them is as perfect little seeds. In a supercooled cloud, pure water vapor has a really hard time freezing on its own. But these little bioaerosols, they provide the perfect surface, like a template, for an ice crystal to form around. And getting that ice to form, that is the critical first step for making rain and snow.
All right, so if biology is out there actively making weather, that is a gigantic claim. So the next question is obvious, right? How on earth do you measure that? How do you put a number on the creative force of life itself in the atmosphere?
And this is the absolute core of this new research. Scientists have proposed a new variable. They call it psi. Now, let's be super clear. Psi is not some new fundamental force of nature like gravity. A better way to think about it is like a new lens, or maybe like a bio-weather dial that lets us measure the collective power of these microbes to organize and shape their world.
Now, what's really clever here is how the researchers avoid a classic scientific trap, circular reasoning. To figure out the value of psi, they only use what they call upstream data, stuff like temperature, humidity, and how many of these INP microbes are around. They absolutely do not look at data about rain or clouds to calculate it. This is a big deal because it ensures that psi is a genuine predictive tool, not just a fancy way of describing weather that's already happened.
And this just perfectly shows the scientific process in action. They aren't just picking one formula and crossing their fingers, they're testing a whole bunch of different mathematical recipes for psi. I mean, is the effect of these microbes additive, where some factors can make up for others, or is it more like a switch, a gated effect where you need all the right ingredients at once? They're letting the data tell them which model actually fits the real world.
As you can probably guess, a theory this revolutionary needs an extraordinary amount of proof. So the researchers have laid out this really rigorous, multi-stage plan to put psi through its paces and prove it's a real, measurable thing.
This whole process is like a gauntlet, and it builds in 3 phases. First, they start small and controlled, in the lab, using these cloud chambers to see exactly how microbes affect ice. Then, they take it outside into the real world for a field test, watching what happens naturally. And finally, the big one. They scale it all up, testing across multiple sites and plugging their findings into the big, complex weather models like WRF-Chem.
And this, right here, is what makes it real science. This isn't just a cool idea, it's a specific, testable, and falsifiable prediction.
The claim is that by adding this psi variable to the weather models we already use, they should be able to improve how well we predict rain and snow by a measurable 5 to 10%. If they can't hit that target, well, then the hypothesis gets rejected, or it's back to the drawing board.
But what's almost as surprising as the idea itself is how accessible this science is. I mean, you can set up a basic measurement station to get the data for this for just over $5,000, using mostly gear you can buy right off the shelf. So you've got this relatively low cost to get started, but the conceptual impact is just absolutely massive. This quote from the paper really says it all. We're talking about shifting our whole worldview from seeing life as just a passenger on a physical planet to one where biology is a co-pilot, a co-actor, that is actively shaping the physics all around it.
So this all leads to the big so what question. If psi is real, what does that actually mean for us? What does a future look like where we don't just understand this biological force, but we can actually predict it and maybe even work with it?
This really is a true paradigm shift. Think about it. In the old view, biology was just background noise and weather models. With psi, it becomes an active, dynamic force we can measure. This could lead to way better forecasts for everything from summer rainstorms to dangerous airport fog. And maybe the most profound thing, it changes how we see evolution, from life just adapting to its environment to life actively co-creating the very environment it lives in. And just when you thought that was mind-bending enough, the paper hints at an even more speculative future. I mean, if these microbes represent some kind of collective, creative intelligence that can structure the physical world, could we harness that? This opens the door to something that sounds like it's straight out of science fiction: biohybrid computing. And that leaves us with one last, truly provocative thought. Could this emergent, creative force we're finding in microbiomes, the very same thing that helps make our rain, one day be integrated with our own technology? Could living systems actually help make our computers more powerful, more efficient, maybe even more creative? We have no idea what the answer is, but for the very first time, we actually have a framework to start asking the question.